skin lesions in general. But before I do, because I will be introducing dermoscopy, I'm just going to do a quick run through the principles of modified pattern analysis, which is descriptive dermoscopy. Now, there are lots of different types of dermoscopy, but this descriptive dermoscopy is the easiest to start with. So what we need to remember is that skin lesions are made up of structures, lines, dots, clots, and structural zones of varying colours. These form neat patterns in nevi, and they don't in cancer. That's pretty simple. Okay, now I've got a list of names here. I don't know if it's complete, and there may be some people absent, but I'm going to pick on people, and I'm not at all sorry, because I don't want to do all the talking. Great, Polly, I want you to look at the ceiling. This is really easy. Can you describe what you see on the ceiling in terms of lines, dots, clods, structureless zones?
Was it a combination of dots, lines, and a varying pattern?
I should give you a pointer. Let me help you. If we look at the ceiling panels, they are separated by lines and made up of dots. If we look at this air conditioning thingy, it's got a central structureless zone from which come radial lines. Over here, we have concentric circles. Now, I didn't tell you about circles. Circles are joined up lines. So anywhere you look can be described in terms of lines, dots, clods, and structureless zones. And that is descriptive terminology. But most of us would actually call this complex thing a projector. We wouldn't say it's a box made up of lines that are intersecting with some squares and different colours on it. And that is morphological. So this morphologically is a projector, and a ceiling made up of ceiling panels with some air conditioning units. But we can describe them as lines, dots, and clods. And that's mostly what we're going to be doing today. But we will bring in some morphology as well, because sometimes it's rather tiresome just saying it's a dot with a circle around it and a curved line outside that. It's much easier to say it's a strawberry pattern. So patterns of lines. So in nevi, we have lines that intersect, and we call that reticular. So a reticular pattern is intersecting lines. On the soles of the foot, the lines don't intersect, and they're just parallel to each other. But you can sometimes get some dots in between them. Patterns of circles aren't that common. This shows a pattern of brown circles, so joined up lines. And this shows a pattern of white circles. So there's a little dot with a white circle around it, a dot with a white circle around it. So this pattern is white circle pattern. This is brown circle pattern.
So you wouldn't say the brown one is reticular because it's a little bit more curved each line compared to the previous one? Or would you say?
The reticular means they're intersecting, whereas circle means they're joining up. So that is a circle, and that is a reticular pattern. But of course you can have both together, because maybe that becomes your circle. So they're not pure. You certainly can. I mean, one person will describe reticular where another is saying. There's, unfortunately, that's true of life. You know, some people will call it an elephant and someone else will call it a mammoth. They're pretty similar. The clod is a bit of earth. So if you throw a clod, it could be any shape by the time it lands on the ground. So clods can be round or oval or square or any shape you want to make them. I've drawn clods here, various shapes. They can be different colours too. Morphological terminology would say this was a globular nevus. Or descriptive terminology would be say it was made up of brown clods. This is also made up of brown clods, but morphologically would be called a cobblestone pattern. So there's more than one name for dermoscopy. So dots are found in dermoscopy as well, and they can be various colours. So if something was all dots, we would say it had a pattern of dots. It might have a pattern of grey dots, or it might have a pattern of red dots. Obviously, red dots are blood vessels. But sometimes you can't see any lines and you can't see any dots or clods. And when you can't see lines, dots, or clods, then we call it structureless. Now, the original morphological dermoscopy used the term homogeneous, but that's not quite the same as structureless, and I think structureless is more useful. So some of you may, if you're very close, decide that you can see structures within this. So take your glasses off, we'll move to the back of the room, and you'll be convinced it's structureless. You can have more than one zone, so this is made up of at least 2, if not 3 zones, but each of them is structureless.
So when you asked the previous one, the seen image, the sort of skin colour two components one, to me it looks like it would give some depth to it, but you're not really interested in white structure?
No, just the distribution of colour, if you like. Yeah, so we're looking at a 2-dimensional image, so that's good. Now, there are a few lines here, but they don't count. You have to have 30% of the lesion to say that it has a pattern. So yes, it has a focal area of lines, but the pattern is structureless. You can have more than one pattern and more than one zone. So this has a structureless blue-grey colour and a structureless brown colour. This has a structureless central area and dots around the edge. Now, some of you will say they're not dots, they're clods. So what is the difference between a dot and a clod? Its definition is that a dot is too small to see the shape of it, and a clod, you can describe it by shape. Now, what we see on a projected screen is much clearer than you're going to be looking down a tiny dermoscopy and trying to work out whether it's a dot or clod. You will know with this, whereas here it might be more difficult. So if you have more than one pattern, the pattern is often concentric. So this is around that. This is around that. So here we have a pattern of clods in the middle, a pattern, if you look very closely, of lines around the edge, and a structureless zone in between. So we've actually got 3 concentric patterns. But instead of being concentric, your patterns might be repeating. And this is a repeating reticular pattern. So there are lines, a bit hazy, but there are some hazy lines repeated over and over again. And in the middle, they become so close that you can't see the lines, and they've become structureless. Remember, this is biology, not geometry. Oh, what a difference when suddenly the pattern is lost. We still have those same basic elements of dots and lines and clods and structureless zones, but the patterns have disappeared, or you've got multiple patterns in a disordered fashion in melanoma. So I think some of you will be able to see some lines. We can certainly see red lines, but maybe some brown lines up here. You can certainly see clots, and there's a skin-coloured structureless zone. That doesn't really count because it's the same as the background, and maybe a pinkish one. And here our lines are nearly lost, our clods are nearly lost, and mainly it is structureless, but disordered in distribution. Okay, so that's the basics of dermoscopy, and the rest is going to be practice. Many of you will be aware that there's more than one kind of mole, and there's freckles as well, just to add to the confusion. So I've just been preparing a talk for next Thursday on nevi, and it's really a big muddle. The classification of melanocytic lesions is still under development, and there are many different ways that you can look at classification of melanocytic nevi, and none of them are right. But let's have a shot. First of all, we need to define what is a benign melanocytic nevus. We know it as a mole. And it is a collection of nevus cells. So these are melanocytes, but they're not behaving like normal melanocytes. They may produce more pigment or less pigment, and they look different microscopically. They tend to be rounded up, but sometimes they're spindled. They're mostly not dendritic, but occasionally they are. And they form groups together. So you have a nest of nevus cells, or a cord or a fascicle of nevus cells. And that's what makes the nevus. They can be present at birth, congenital, and in that case they are developmental from very, very early in development. For example, if you had one on your eyelid, a congenital nevus on the eyelid usually is on both the lower and the upper eyelid, which tells us that that developmentally occurred before the eye split, so before the eyelid split. And that's at around 8 weeks development. So they're very early on congenital nevi. Tardive means it looks like a congenital nevus but wasn't present at birth, so it came on later on. And acquired. So this is a difficult word. Acquired means it's not congenital, but I've just told you there's in between one called tardive. So when does a tardive become an acquired? I don't know. This was Professor Bernard Ackerman, was probably the most famous dermatopathologist. He died about 10 years ago. So he classified melanocytic nevi according to this list, basically. Congenital, superficial, deep. Blue, combined, dermal, ulnar, mesha, halo, Sutton, recurrent, Clark, Spitz, Reed, junctional, compound, and dermal. So you can have junctional, compound, and dermal of any of those. But that's not quite right either. The classification of congenital nevi is simply done by the diameter of the nevus in an adult. But of course, when you're usually looking at congenital nevus, it's in a child. So you have to figure out what size is it going to be when that child is an adult to determine whether it's small, medium, large, or giant. And there are various clinical types that don't have names. Tardive nevi appear later, and under the microscope they look at the same as a congenital nevus. So I'm sure some of you have been surprised when you've excised a nevus and it's come back congenital nevus, and yet the patient told you that it had only recently arrived. Now partly the patients are wrong and it didn't only recently arrive, and partly the pathologist wrong, it's not congenital. But there are certain features of the histology that tell us that it's congenital-like, or developmental. And one of the easiest to remember is that congenital and congenital-like nevi are folliculocentric, so they tend to have big fat hairs in them. Whereas an acquired nevus is superficial, so just a flat lesion or flattish, and follows immune suppression or sun exposure. So Kiwi kids have more moles than European kids on the whole, especially Kiwi grown-ups. Actually, the kids are now looked after and they don't have as many moles as they used to because they're not exposed to the sun. But exposure to the sun increases the number of nevi. And what we don't know is, does it increase the number of congenital nevi? Or at least the ones that are Tardive nevi? We think it probably does, because New Zealanders have lots of the dermal nevi as well as the superficial ones. But what we are sure is superficial ones require sun and or immune suppression. So children that have been exposed to immune suppressing diseases or drugs have more nevi than those who don't have those predispositions. Okay, which of these melanocytic nevi is congenital? Okay, we have some going for 2 and some for 1 and some people giving up. Don't give up, please. Thank you. I'm going to ask Jane Burrell. Where's Jane? Jane, could you tell me which you chose and why?
I thought both.
Good. And what made you think both?
A, because it looked quite deep, and I'm guessing there's hair follicles in there, but I'm dreaming because I can't see properly. And the other one looks so big.
Yeah, it's huge, isn't it? So both look rather odd, and that's very typical for congenital nevi. And if you can't see, do you want to come closer? So both were present at birth, and we usually recognize that just by gestalt. We don't need to ask a question. And Jane's right, we recognize it because they're thicker on the whole and larger in diameter. But congenital nevi can be flat, and acquired nevi can be thick of the Tardive variety. So present at birth tells us it's congenital. A is medium-sized, because it's more than 1.5 centimeters. And B is giant, because it's more than 40. So if you want to know how big will it grow, does a childhood nevus grow? So this is a baby with a brown birthmark or a congenital melanocytic nevus, 6 centimeters or so. We can multiply according to this little crib, and you don't need to remember because it's on DermNet. Okay, second question. We've got the same one on the right and a different one on the left. Which of these has a greater than 10% chance of developing melanoma in the lifetime? Okay, so most people think it's the one on the right. Bronwyn, did you select either of those?
I selected B, but I don't have a good, really sound reason for making it, except that I assume that changes within something like that might be quite difficult to do.
They are. In many giant melanocytic nevi that have watched lifelong, can be really, really difficult to detect. And some people think it's a waste of time because they're probably not going to be curable anyway. So I'll just work through that. Neither is the answer. Giant nevi have a 3 to 4% lifetime risk. Okay, and it's only if they're more than 40 centimeters. So that tells us that anything smaller than 40 centimeters in diameter does not give as much as a 3 to 4% risk of melanoma. So we only think that these giant ones should be kept under monitoring, and then anything smaller does not require monitoring. So if a parent comes and says, what are you going to do about this birthmark? You shrug your shoulders and say, I'm not going to do anything. It's just one of those things. If the child wants it removed when they're older, they can get an opinion, but it's going to be very tough and there's going to be a big scar. Let's take a photograph. It's going to grow with age. Here's a copy of the photograph. Please bring your child back again if you're concerned. End of story. But if they have a giant melanocytic nevus, they need to be under the care of a pediatric dermatologist.
So what are the risks if they are pretty large, but obviously lower.
It's not unknown. It's been difficult enough to get the figures for 3 to 4% for a giant. We don't know the risk for smaller. And it's negligible, probably. As I said, you have to see 300,000 to 1 million nevi to pick up a melanoma. And that will include some congenital nevi. And it's not even known if the risk is greater than acquired nevi, and it may not be. And there are lots of complications to this, because a nevus and a melanoma look exactly the same when they're first starting out. And so if you say to someone, did you have a mole here before, when you look at their melanoma, they'll say, yes, I had a mole there and it's changed. But of course it was a melanoma all the time. And you just didn't know that, because you didn't take it out. So you can't prove that it was or it wasn't. But it, almost certainly, 8 or 9 out of 10 melanomas arise in normal skin, and they don't arise in a mole at all. So it's only 1 or 2 that arise in moles. And the story is much more complicated than that, because the pathologist will often see nevus cells in the pathology. So they'll report, this is a melanoma, and I can see a nevus as well. Now that doesn't mean that the melanoma grew from the nevus. They might just be coincidentally located in the same part of the skin. And so it gets complicated. So with molecular genetics, they've tried to determine whether maybe they have the same mutations. So that a nevus might have a BRAF mutation, and the melanoma might have a BRAF mutation, and then you would say, well, there you go then. That proves it. That one came from that mole. Well, it doesn't prove it, because 75% of nevi and 50% of melanomas have BRAF positive mutations. So again, it still could be a coincidence. So more needs to be done on that. We only follow up these ones. We don't follow up those ones, apart from just saying here's a photograph, come if you're worried. So in these ones, we also know that many, well, I've just told you, 96% of them don't ever get a melanoma. So these are extremely rare. In 30 years of dermatologic practice, I've probably seen 3 or 4 giant melanocytic nevi. So it's pretty rare. So then I said, well, what's the point in following even these ones up? I mean, we do and we recommend it, because usually the melanoma is not treatable, and the melanoma occurs deep in the skin, not on the surface, and it may not even occur in the skin. It might occur within the spine or cord, or even in the brain as a primary. You can't do much about that. So, unfortunately.
Would you monitor with another MRI?
Yeah, well, of course, that's the other thing. Do we do MRI or not? And there are people who say, let's do MRI and prove that there's leptomeningeal melanocytosis, which means melanocytes in the brain and spinal. So what if you prove it? What can you do about it? You can say, oh, look, your brain's full of melanocytes. Oh, dodgy. I think most of us don't want to know, but it depends on your philosophy and the parents.
What's the satellites? What does that mean?
This 3%, if they look at the group that do have melanoma, it's more common if they have not just one giant nevus, but they have lots of little ones as well.
But, so are you saying that by we have 60% of lifetime risk of melanoma, or
no,
or 60% of that 3 to 4% of the ones with satellites?
Something like that. I can't give you the actual proportion, but yeah. And so some people would do the MRI to find that 10% or 60%. Okay, what about this? Which of these two is congenital or are congenital? Okay, so lots of people think there's 1, and some people think there's 2. Okay, so Pina, is that the right pronunciation?
Yes.
Which did you choose?
I chose both.
Because?
Because of the hair.
Because of the hair, exactly. But what happened is, A was present at birth, but this came on later. But it's a very good example that you can't actually tell the difference. Perhaps size helps you. But a nevus that occurs in childhood as opposed to prior to birth may have similar characteristics. And big fat hairs is a clue to early onset. So when a patient comes and says, "This mole is new, doctor," and you see big fat hairs coming from it, you go, "Oh yes, actually you've had that one for a long time, but has it changed?" They do mature. So those start off at, they probably develop before the age of 10, or most of them will develop before the age of 10 years, and they start as a flat brown mark, and then over a period of time they become thickened up and develop the hair, particularly around puberty and adolescence. And some patients have hair, big fat hairs coming out of all their moles. It's quite unusual to see that, but some of them do. And they sort of have tufts of hair here and tufts of there. They usually shave them, but that may not be the case. So terminal hair tells us that they're developmental and they occur early, and that they have a dermal origin. Now, hair is an epidermal structure, but it pokes down into the dermis, and we see dermal nevus cells that are folliculocentric in congenital and tardive nevi. Sometimes it's easy, and what about if there's no hair? Does that help us decide whether they were present early in childhood or not? Which lesion began before the age of 10? It's complete guesswork, so guess away. I know the answer. So some of you are struggling with that one. Some of you think it definitely neither began before the age of 10. Very good. So we're going to hear what Heidi thinks. Where's Heidi?
A complete guess of number 8.
Yes? Mm-hmm. That's a completely guess correct, but actually B is also correct. So there are nevi that we recognize in children as being more prevalent than in adults, but that's possibly because they change into something different in adult life, or maybe it's that adults have more spots, so the number of childhood type is therefore reduced. So this type of bumpy mole is the kind we see in children, but we also see this kind too, which has a rim around the edge. And on dermoscopy, it's much clearer that this is made up of clods. It's a globular nevus, and this is made up of more or less structureless. Some of you will see some structures, but that's because it's blown up on a screen, and has a reticular component. So this is a dermal nevus, and this is a compound nevus. So there's a dermal component in the middle and a junctional component on the end. So dermal nevi are childhood nevi, and that those acquired ones that occur when we later have been out in the sun are superficial, and they are flat. So this will be slightly bumpy. So recent studies have suggested that this age 10 is not a magic number, and that actually you can develop your tardive childhood onset nevi when you're older than 10. And maybe you might even be 30 or 40. So most of them develop in childhood, but maybe a few pop up later. And because they're dermal, deep down in the skin, the sun really hasn't got anything much to do with it, because the sun doesn't penetrate that deep. The sun is only involving the outside layers of the skin. These ones with a rim around them are seen on the trunk and the scalp. And they're very, very common in children, where we can see the scalp. through the hair.